Okay, so now we're in part 2, and I just realized that there's an error here. It's the same problem from part 1, which is it's too long. So what I'm gonna do now is create a part C, and I'm just gonna put this back here, and then I think hopefully part C. I'm just gonna rename this to part B and part C. So part A and part C. Hopefully there's no problem because um because when I was testing this out it was all good. So I'm not exactly sure what happened. It's probably just because I'm recording, it just thinks it's too it's not as it's not really powerful. But anyways, uh yeah, so this is gonna be part B. And size, oh, this is meant to be container size. That's interesting. Yeah, so if you get that problem, just try to break down the this thing. So and you might not get the problem because you're not the one who's recording the video. So yeah, because I want to create another function which is getting the distance from. So this is I'm just gonna do position A, and that's gonna be a CG point. So I'm just trying to measure the distance, so so that the person can be far away enough from the player. So I'm gonna do pos A and pos B. So these are just position A and B. CG points. So they're going to both be CG points. And what I'm going to use is, trigonometry, or that Pythagoras theorem. It's pretty, you don't really need to know much about it, but what's going to happen is that I'm just going to return a CG float once again, or just another number, and I'm going to return the square root, of point A, or pos A, dot x minus pos B dot x. And what I have to do is multiply it by itself. Actually, what I'm going to do is create some variables. So a squared. So because what I'm going to do is multiply it by itself, and that's how you square a number or a value. I'm going to do the exact same thing. So you can see I'm doing the same thing for the x position. I'm doing the same thing for the y position now. Now, for Pythagoras theorem, it's a squared plus b squared equals c squared. So I'm just going to do a squared plus b squared, and that means it's c squared. C squared is just the distance, but c squared, that means it's a squared value. So I want to do square root, so you're just left with c, and c is the distance. Anyways, if you didn't get that, that's fine. That's all good. You don't really need to understand it, but this is what you need to measure a distance between two positions. Now, I'm gonna scroll back down here, and what I'm gonna do is it's not I guess the best way of doing it, but I'm just gonna make sure that the person's not too close to the player or you, and if it's too close, I'm just gonna reset the position or create a new position until it's far away enough. So I'm gonna do for pos A, I'm gonna do person.position, and for pos B, I'm gonna do person dot or player.position. And remember, I'm putting in this in a while loop. So I'm just doing this. So you're measuring the distance, and make sure it's less than the social distancing length, which I'm gonna specify. So I'm gonna put in person.size.width, and so I'm pretty much getting the size of the person, and I'm gonna multiply that by the social distancing length times 5. So what I'm just gonna add some space here because these variables are very important. So VIP. I'm just gonna make them VIP constants. What I'm gonna do now is create the number of people, or set some constant. So for number of people, the maximum or the maximum person, the maximum speed a person can go. Of course, that's gonna speed up once we keep bouncing. It's very subtle, but you'll see later. Max person speed dot cg float, and that's gonna be around 100. 100 seems kind of fast, but it's not actually too fast. Now, finally, I'm gonna create this time a variable. Actually, I'm just gonna rename this to variable. And I'm gonna do var social distancing length. So now I'm just creating social distancing length, and that's also giving me a CG float, and that's just gonna be 1.5. Because, well, in Australia, it's 1.5 meters. If you're using the imperial system, it's 8 feet, but 8 feet is not 1.5 meters. So just say 8 feet if you're, let's say, from the US. So that's how far you should be from, I guess, from each other. So, yeah. I'm putting in real social distancing lengths, even though it may not be too real in this game, because the scaling is not completely perfect, but it's good enough. Now, as we start here, I'm going to divide this by 2, because what I'm going to do is, with the social distancing length, basically I'm just making it, I'm pretty much dividing it because each person's going to have a bubble of the social distancing length. But if it's 75 centimeters, one person has 75 centimeters of their bubble, and the other person has 75% or 75 centimeters, and you add them up, that makes 1.5 meters, which is the social distancing length, which is why I'm dividing it by 2. Now, okay, with the distancing, social distancing length, I'm just gonna make sure it's less than the person's size dot width, and I'm just gonna multiply this by the social distancing length times 5. So it's 5 times the social distancing length. It's kind of hard to say if you're saying social distancing length over and over again. Anyways, if it's less than it, then inside this block, I'm just gonna copy and paste this, and just do that. And I'm just going to, so actually here, what I'm gonna do is, cut this here, the add person people dot append lines, and then just put that down here. And now that's pretty much done. So what I can do is, I'm just going to do a for loop. So I'm going to put in nothing because we don't need to access the how many times it's looped. So I'm going to do 1 dot 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 number of people. So it's going to do, in this case, 1 to 5. So it's going to create 5 people. And dot dot dot, one more dot. And I'm going to do create. Just going to put in the function create person. So if I run the code, oh, there's an error. Let me just put this down here. Oh, it's number of people. That is number of people. I'm just gonna, move myself back up since that's fine. And I'm just gonna run my code and see if it's all good. Now it's loading, so if we just wait, there we go. And now you can see that it's created 5 people. You can see there's one person there, which is hiding behind me. Maybe it's a little shy for a camera, but it's alright. So yeah, that's all good. We've got the people, and what I'm gonna do now is, I guess, not really the hard part, but the big part of it, or one of the main parts of this game. And so what I'm gonna do is drag the person around. And if you're wondering if the player around, dragging the player around, but if you're wondering, maybe the people might overlap on top of each other, that's fine because we're going to add physics bodies later for collision, and that's going to be all good because once you create the person, or once we use the physics bodies are gonna make sure that they're not too far apart, or that they're not, I guess, overlapping on top of each other. So and also it's gonna use a social distancing bubble, so it's just gonna pop out like that. So that's fine. They're not gonna overlap. Now for dragging, we're gonna do touches began, or create a function called touches began, and this is just gonna handle the touches. And one thing we're gonna do is create some new variables before we start doing this. I'm gonna create a variable called game over. So if it's just a text, is it game over? I'm gonna set it to false because we want the player to play, not play. So we want the player to actually have a chance or have a go of playing the game. One thing we want to also do is create another variable called moving player, and this is just to detect or to check. Oh, are we going to drag the player around? Because we're going to set that at the start, and you'll see why later. And so what I'm going to do now is create, or actually I think that's all we need to do. Oh, what else we need to do is an offset. So let's say this is a player and you drag it from here. If you don't have an offset, it's going to snap here. So it's going to snap to the center. So we're going to use the offset so it can be dragged around here. And I'm just going to make this a of type CG point. And I'm going to make this add an exclamation mark at the end because we know that it's going to be there's going to be something in it once it's accessed. Okay, now we're going to do with the touches began, where almost it's going to be pretty simple, hopefully, or it is pretty simple because I've tested it. So I'm going to check. Oh, is it game over? If not, then we can keep going. So we can pretend this guard statement. It's like a guard. It's a guard checking if it's game over. If not, it'll let you go through. If not, then it's gonna do something in this else statement, and it's just gonna be returned. So it's like it's kicking you out of a function. So yeah, a guard. If it's not game over, it'll let you through. If not, then it's it won't let you through, and it'll just kick you out of wherever you are. And also we're gonna do guard let touch because we're gonna make sure that there's actually gonna be if it's touched, and it's a little ironic because this is when there's actually a touch, but it's an optional, so sometimes it might not be touch. I don't know, maybe there's a bug, but I've tested it. There's definitely not a bug with Apple's software, but yeah, so that's all good. Now, once we've gotten the touch, let's see. Oh, touches. It's a plural form. So now we're gonna get the touch location, and that's gonna be touch.location in self. So that's gonna pretty much, I'm getting the location from the screen. Then it'll output a location. After that, I'm gonna check the touch to where, and that's gonna be nodes at the location that has been touched. Now, what we're gonna do now is loop through all the touches. So for node, or all the nodes that have been touched. So for node in touched, or touch nodes, I'm gonna rename this to touch nodes. That's a better name actually. Touched nodes. For node in touch nodes, if let sprite equals to node as an sk sprite node. So we're making sure it's a sprite node. So it's because a player is a sprite node. So it's kind of like a first stage of checking. Once that's done, if the sprite is a player, then I'm gonna set moving player to true. Actually, I don't really need this part. because I can just check if it's a player. Yeah, never mind. If a sprite is, if the node is a player, then moving player is true. Whoops, indentation problems. Anyways, that's fine. Now I'm gonna set the offset in here. So, CG point, and that's gonna be, for this, it's gonna be the touch location for the x position. It's gonna be touch location dot x minus player dot position dot x, and my Apple Watch thinks I'm saying "Hey Siri" like multiple times, and it's like pinging me. It's fine. I'll just should be all good. Anyways, for the Y, we just do the same thing but for the Y position. Now that's the first part of the grabbing and moving. Touched for node. There's a problem here. Touched nodes. Very good. It has to be past tense. Just because I just like it to be grammatically correct, or just to make sense. Because if it's touch nodes, it just doesn't really. I don't know. I just like it, like that. Anyways, so now in touch, I've also created another function called touch move. Now this is where we're actually moving the player around. So guard. So we're gonna do another guard. So guard game over. So make sure it's not game over and the player is being moved. If not, we're just gonna do return and get out of the function or kick it. Yeah, just don't do anything really. So once that's done, I can just copy and paste this, and so there we go. That's the touch location, and then I'm gonna create another constant called new player position. Now this is gonna be a CG point, and this is gonna be so for the X position, it's gonna be the touch location. Actually, what I can do is just copy and paste this, because it's almost the same, except this is offset, so we're taking away the offset. So there we go, we've got the offset, we've added compensation for the offset, and now because this is Swift Playgrounds, it may not be very smooth, so I'm doing player dot run sk action. So we're going to actually make an action. So we want this to be move. So we're going to move this to the this is not the offset. I just realized this is meant to be the new player position. I don't know why this was different. There we go. Move to new player position, and duration. I'm just gonna make this 0.01 seconds, because it's fairly quick, but we just want this to be smoothened. If you want, you can even add a note here if you don't really understand. It's just for smoothing. So if you're coming back to this and you don't understand what this is for, it's to smoothen. Yeah, so that's why comments are good. And of course I already explained it, so you don't really have to add the comment. I'm just adding it there for my own, just to make it easier for me if I ever want to come back to this. Now, for touches ended, I'm going to set moving player to false. There we go. And that should be almost it. I'm just going to run my code and see if it's working, or if it's gonna work properly. Hello guys, this is me, Yuma, from One Day in the Future. I've come back down here to say that after this snippet of video, I'll experience a ton of lag playing the game. Basically, I thought it was something to do with with all the screen recording and all that, but actually the problem is, down here, there's a speed dial icon, so if you press on it, you can toggle this option called enable results. So if you turn it off, then you'll find out that the game is going to be a lot smoother. So that's all I have to say. I'm going to jump back to the future, so see ya! It is doing it, but it's extremely laggy. That's probably because of the recording, but for you it's going to be smoother. Actually, what I can try doing, under the SK view, I can request a preferred frames per second, and I can make that 60. So it's 60 frames per second. Now it's probably gonna be quite slow actually. Yeah, it's still quite slow, but it's faster. Yeah, it's of course this is Swift Playgrounds and I'm recording, so for you it's gonna be a lot smoother. What we're going to do now is add some physics buddies to the player and the um, person, or for each person. Now, for a player, what I'm going to do is I'm just going to this is people, and for the player, I'm just going to create a physics body. So if player.physics body equals to sk physics body, and it's going to be a circle of a radius, and that's going to be player dot size dot width times 0.5 plus the social distancing length. Now I'm adding the 0.5 because 50% of the player's width is pretty much the social, or is pretty much the radius of a player. Yeah, dividing the player's width by 2, you get you get the radius. Now for player, what I'm going to do is do .physics body, and I want this to be not dynamic, so it can't really be moved. So it's like a rock or a boulder. You can't really move it. And also it's not going to be affected by gravity, so it's not going to fall down forever. Or actually, there's going to be a boundary, so that's fine. But anyways, so I'm gonna set is dynamic physics body player.physics body dot is dynamic, and that's gonna be false. Now player.physics body. Oh, and what I'm going to do now is create some category BitMasks so I can identify the player's physics body once we're doing the collision detection. So down here, or on the left, I'm going to create a new file, and this is going to be called BitMasks. BitMasks, and I'm just going to create a struct. A struct is pretty much like a class, but there are some differences which I'm not really going to go over today. So BitMasks, and I'm going to create, I'm going to make this a public struct. Now, I'm going to create a few variables, and these are going to be static let. So you don't actually have to create an instance of BitMasks to actually access the different variables or constants. I can just, create different, I can just create different, I guess, constants, and they can be accessed using the static property or the static keyword. So first of all, it's a player, so that's going to be an unsigned integer, or just pretty much a whole number, and that's going to be 1, and then there's going to be 2 arrows pointing to the left and 1. So that's kind of indenting the 1. So it's like 1, 10, stuff like that. So I'm going to do that 3 times, and this one's going to be for the enemy, and this one's going to be for the normal person. So the uninfected person. I'm just going to call this uninfected person. Now this is going to be 1, 2, and 1, 3. So that's all good. So Now I'm gonna set the player's BitMask, physics body. So this is like an identifier for physics bodies. Uh, Now you might be wondering, why can't I just check for check if it's a player? Well, it's just easier to check the BitMask for each object once we do the different once we do the collision detections. So this is going to be category BitMask, and this is going to be of BitMasks. We're going to assign this the player BitMask. Now, with a BitMasks, these can be like any number. It could be 1, 2, 3. I'm just doing this because this is what I'm used to doing. So I can just I'm gonna copy and paste this and put this as contact test bitmask, and this is gonna be bitmask.enemy. So if it touches the enemy, we're gonna handle something or trigger the game over. Now with this, I think that's all we really have to do for players. For the person's a little different, because there's a few different things. So I've just copied and pasted this. So I'm just gonna change this to all person, and there's a dog barking. I'm not sure if you can hear it, but yeah, sorry about that. So person, and so for a person, we're gonna check if it hits the enemy as well, because then that's how it gets infected. And for persons, for a person, and this is going to be an uninfected person. That's the category BitMask. And this is not going to be. This is going to be dynamic, so you can be hit by other people, because this is going to be like a chain reaction bouncing off different people and all that. So I'm going to set affected by gravity to false. So it can be moved, but it can't be affected by. It's not going to fall down or anything like that. For that, so once that's done, I'm just going to let's see what else I can do. I can do person. I'm gonna set the friction values actually. So dot friction. So this is gonna be 0. So we don't want it to slow down at all. So I'm gonna set. So there should be around 4 of these. So angular damping. That's gonna be 0. Restitution. This is the amount of energy that gets kept once it bounces off. So actually, it's gonna ever so slightly get faster and faster. So I'm setting it to a value that's higher than 1. So it actually gains more energy when bouncing, because I want to make this a little harder for the player once they get further and further into the game. So affected by gravity, I'm gonna add another one, allows rotation equals false. So it won't be able to rotate or do stuff like that. One final thing is for the physics body. Oh, I've already said the friction of the physics body. Never mind. So I think that's all there is for today, or for this part. Because it's again kind of getting long. It's a bit of a long game. Kind of takes a bit of time to make, but we'll get there. We should be getting there in the next part. So see you next in part 3.